Hey guys, welcome back to Consistent Code. So today's problem of the day is minimum characters to be added to at front of a string to make that string a palindrome. For example, if you're given a string A, B, C, then the minimum characters that you need to add are B and C, and that makes your answer as 2. Similarly, if you consider this string, you can just see that this substring is already a palindrome. So if I add this last character A in the starting, then I will get a palindromic string. Hence my answer becomes 1. That is this only last A character. Now let me just walk you through the code. I have already completed this problem. So, and before that, I would like to mention something that you're gonna be needing Maneker's algorithm to solve this problem. What is Maneker's algorithm? It is an algorithm to find the longest palindromic substring in big O of n time complexity. So if you don't have any idea about Maneker's algorithm, so I would highly recommend you to please first learn that and then try this problem, because you're not gonna get anything if you don't know anything about Maneker's algorithm. Because what we are gonna do in this problem, it's just a modification of Maneker's algorithm. I again repeat, if you have no idea about Maneker's algorithm, you first need to learn that algorithm and then come back here. Now let's get started. Initially, as we do in Maneker's algorithm, we just fix the center and the right pointer at 0. We take and what is the modification we are doing? We are just creating a variable, let's say answer, right? Let me just give you the intuition. Basically what we are doing, suppose this was a string, then what will be our answer? Our answer will obviously be the one if we can find a substring which is a palindrome having the starting index same as the starting index of original string. What I mean is that if you consider this substring, this is having starting index which is the same as if I consider starting index of the original string. This A is the starting index of this original string as well as this substring, and this substring also needs to be a palindromic substring. Then if I get this substring which is having the starting index same as that of original substring and it is also a palindrome, then whatever is left in its right becomes my answer that I need to add in the starting of the string. And all I need to do now is find the maximum string which is having starting index same as that of original substring and which is also a palindrome, and I need the maximum length of such a substring if I can find it. All right, so what we can do, we can use the Maneker's algorithm to find the longest palindromic substring, but the Maneker's algorithm gives us the longest palindromic in the complete string, and it does not specify that its starting index will also be the same as the starting index of original string. So this is the place which we are going to do the modification. So using Maneker's algorithm, we have initially added the hashes and the dollar in the string, and after that we have just created uh, uh, array p to store the maximum length of palindromic substring considering that point as the center, and then we are iterating for every index as we do in Maneker's algorithm. Now the modification which we are doing, this complete is a Maneker's algorithm only. The only modification is this if line. So whenever we find that we are getting a palindromic substring, then we are checking if we are having this thing, that is, suppose I am here, then I'm checking if my p of I, that is the longest palindromic substring which I am getting, and the index which I get in the starting of this string, which is in this, if I am having the string which I have modified, then it should be like dollar, then hash, then a, then hash, then a, then n hash again, then c, then hash, e hash, c hash, then a hash, then a hash, then a hash, and then an at the rate. So suppose I am here, then what I am checking, if I'm getting a longest palindromic substring using Maneker's algorithm at this index, then the only modification I am doing is I'm just checking if the pi, which is the number of elements in the left and right which are exactly same. In this case, these all elements are same, so I'm just checking if this index minus number of these elements minus 1 is equals to the dollar. That means if I'm getting palindromic substrings from this index, and if this is equals to dollar, that means the starting index of the original substring and this of the original string and this substring are same, and that makes my required condition, and hence I can consider this p of I for my answer, and hence I can update my answer to maximum of answer and p of I. And finally, once I have got the maximum value for my answer is the longest palindromic substring which is starting from the index having same index as the original string, the starting index. So that becomes my answer, and all I need to do in this case was I need to subtract this length from the original substring, and I get the length as 8 minus 7, that is this 1, the only character I need. And this is exactly what I have done here, the complete size of my original string minus the longest substring having the starting index same as my original string. And now let me just submit this code. Oh, sorry, I forgot to comment out this line. Now let's submit this code. So we have solved this problem successfully, and I hope you liked the explanation. And if you did so, make sure you hit the like button and subscribe to the channel. And I will see you tomorrow with the next problem of the day.